Okay, let's continue part 3 of lecture 2. We dive into several philosophers. We will go a little bit more for these two philosophers in the coming slide. Okay, as we started to talk about the philosophy and recent and modern philosopher John, concepts of the simulacra and simulation is particularly relevant to our discussion of the real world. Baudrillard proposed 4 stages of representation. So this I'm going to explain about these 4. Number 1, it is reflection of basic reality. So in his concept, including 4 stages of representation, his proposal, he said it is reflection of the basic reality. Number 2, it mask and prevent of basic reality. The number 3 is mask the present, the absence of a basic reality. And the 4th one is it bears no relation to any reality, whatever it is own pure, simulacrum. So what does it mean? So these 4, if I explain more about these 4 in the context of cyber world, so John mentioned that cyber world, number 1, repeat again, is a reflection of basic reality. What does it mean? Let me give the example. Like digital representation, often start as a reflection of the physical reality. For example, we have a road in the physical world. We make a map, road, digital road inside that cyber world. That is reflection of the basic reality. So this is the stage 1. So this is the stage 1. Here explain about the characteristic of his philosophy. Philosophically explained. Number 2, he said that environment mask and prevent how to say. So in the second, John saying it mask or hide a basic reality. So number 1 is reflect of the basic reality. Number 2 is the mask. In the cyber world, we are trying to mask and hide the main object, and we will change that one. For example, we will add more object in the cyber world because we have many free tools. Even differ, we can design some human is much pretty than the original one. We take a picture, but we can use Photoshop or some technique, AI, to make much pretty woman, cyber-based woman, which made from the real woman. So number 3, it is mask the absence of the basic reality. So that hide, many things which doesn't have absence. Something, for example, there is not beauty is absence in the face of some person, but this will be hide that one or add something vice versa. So number 4 is, for this number 2 and 3, as a technology advance, this representation can be more real than reality. For example, for stage 2 and 3, think about photorealistic CGI, computer generated image in a movies, in highly detailed virtual world in the video game. We can create something totally different. And number 4 saying that it generates something that totally in the reality not exist. We make something, we create digital entity that no counterpart in the physical reality. We can make an avatar. AI generated art and music could not be example of this in the real world. This is number 4. He tried to mention about that one. So John Baudrillard warns that as we immerse ourselves in these digital simulation, we risk losing our ability to differentiate between what is the real, what is the representation or fake, potentially living in the world of illusion. Yeah. Then, this is the point for our class. This has profound implication for AI and big data. This point of Mr. John. One is how we do ensure that our AI model train on data that may include, simulacra. Simulacra make decisions that are grounded in the physical reality. So how we ensure that our AI model train on the data that may include, a simulacra means something fake, something simulated, something made. Maybe AI model change reality. How we ensure that what we made from AI is not grounded in the physical reality. So this AI can help us. We need by big data. In a world of the deep fake, deep fake, using deep learning to simulate it from face of one human. For example, Barack Obama talking something. I can use the AI, make Barack Obama saying the word which I like, but never Barack Obama talk about that one. So in the world of the deepfakes and AI generated content, how do we maintain a sense of what is the real? And as we create increasingly immersive virtual world, how do we balance engagement with this digital realm and our physical existence? This is the question John, as a modern philosopher, open for us. This question might, grapple with as we advance AI and big data technology. So I try to open new concept before we deal some techniques. Very nice point he mentioned. So let's dive for another philosophers through the next slide. That was Manuel Castell. He tried to, give the concept of the network society theory. And he tried to say that this theory provides another crucial perspective on the relationship between physical and cyber world. If I try to saying some key aspect of the network society, I could say some point. Number one, global information network. The world is increasingly connected through the digital network that transit traditional boundary. So this is global network information increasing a lot. He said. Number two, he said that information as a power in this society, control over the information flow become a private, a primary source of power and influence. So information as a power. Number three, that transformation of space and time, he tried to mention, and saying that the concept of the physical space and time are, redefined by instant global communication. So we can bring the concept of space and time to the virtual environment. And number four, he tried to mention cultural impact, that the network society shape our new form of social interaction, cultural expression, and identity of formation. If I tell you during Corona, even during shopping by Amazon, culture of book shopping totally by Amazon has been changed. So if we look at in the implication for what is the implication for AI and big data, his network society idea. So if we go for that point, we can see like data as a new oil, new fuel. In the network society, data become an invaluable resource driving development of AI and big data technology. Because he is talking about network society. Network society has many data. And not only data, but also we could say algorithmic government. As more of our lives are meditated through the digital network, this network society, algorithm play an increasingly role in the decision-making process. Another point that network society theory highlight the importance of access to technology and digital, techniques, raising question about the equality and in the AI development, and deployment. So, if I give you some example, like social media platform. In the social media platform, company like Facebook, Twitter, Google, embody the network society, connecting billions of the people, related data, shaping global information flows. So many social platform is the some example of this concept he mentioned, network society. Or a smart city, another example. Urban area increasing related interconnected sensor and data analytics. Global financial markets, high frequency trading algorithm operating through global network environment, making decision in the microsecond. So cluster theory really help us to understand profound ways in which cyber world is reshaping our society and economy as we develop, AI and big data technology. And we must consider how they interact with the shape of these network structures. I think is enough for a philosophy point of view. Just I try to give you some comment that philosophy can open our mind. Detailed concept and modeling which I started to teach like that open our mind. So that's why through this 2-3 slide I open new injection to your mind. Look at AI and big data from another aspect. Okay, I'm going to dive very important and useful ideas which I created and make it connected. You may remember at the beginning of the slide, these lectures, I try to explain that data and algorithm can make a program, and program is equivalence of the problem in the physical world. Program is in the cyber world. You never can find such a beautiful idea in any book or website the way I am teaching, to see AI and why this class AI and big data is together. I'm going to teach. Many classes they teach separately, but you can see because we have an issue in the real world, right? And then we want to solve it by some program. So that is equivalent of problem. So now I am going to talk about that. As we move from the philosophical concept to the practical application, it is crucial to understand the basic concept of the cyber world solution. The famous computer scientific, and Niklaus Wirch, known for developing Pascal programming language. He first time introduced the Pascal programming language. He proposed a simple but powerful equation. What he proposed in his book, he's proposed that one program which including data and algorithm. This formula really encapsulated the essence of how we solve problem in the cyber world. Okay, let's break it down. Data structure. This is how we organize and store data. You may pass these classes already. data structure, including the many techniques like array, like simple list of data, linked list. The linked list is chain of the data point, or trees, hierarchical structure, or graph, network interconnected data points, or hash table for fast data retrieval. This is the data structure. Deal with the data. Deal with space complexity. But in another side, we have an algorithm. Algorithm is how we touch data. This is a step-by-step procedure for solving a problem or performing a task. If I give you an example, like sorting algorithm, like quick sort or merge sort. Another example, search algorithm, like binary search, DFS, depth first search. Another algorithm we will touch, like machine learning algorithm, like neural network or decision trees is the example of the machine learning algorithm. So space management by data structure, and we have one terminology in the course of the data structure, we call it space complexity. Or for algorithm, we talk about the time complexity, because algorithm, time and how we touch data, this is a space complexity regarding the space and amount. So the choice of the data structure algorithm can dramatically affect a program's efficiency and effectiveness. If I give you an example, like using the hash table instead of array can speed up data retrieval from omega n to omega 1 time complexity. Omega 1, omega is the measure, omega n, usually omega n showing by O in the parentheses, we call it n, omega 1. So that means hash table instead of array can speed up data retrieval from omega 10 takes high, but omega 1 is low. So when we change the data structure, many things happen. Or if I give you one example of the algorithm, like choosing the right sorting algorithm can reduce the time to sort a large data set from the many hours to the second. So if I talk about this issue in the context of the AI and big data, data structures, usually we often deal with the massive complex data sets that require, a specialized structure like tensors in the neural networks and distributed database in a big data application. If I talk about the algorithm in the AI, like machine learning algorithm like deep neural network or reinforcement learning algorithm are at the heart of the many AI system. So, understanding this fundamental relation between data structure and algorithm is crucial. So we will dive deeper into the AI and big data technology in later on. So let's continue our discussion a little bit. We talk about the bridge before we talk about the bridge of the real world to cyber world. Now because we bridge the real world to cyber world to solve the problem by program. Now program is equivalent of that one, right? sorry. Bridging the real world. So if you see why transform problem to the cyber world, now let's examine how we bring the real world problem into the cyber world. So as we discussed before, that we have several steps, to manage this one. I want to review again. Problem identification. So step one, how we bring the bridge problem to the program. So we need to understand, identify the problem, clarify, define the physical object problem we are trying to solve. Like, for example, if I explain about that program by reducing traffic congestion in a city, this is the problem. So we need data collect, gather relevant data from the physical world, sensor, survey, using the traffic camera, GPS data, and historical traffic pattern. Then we need to digitalize and structure. Remember, convert the collected data to the digital, right? Organize it, and then we can create the graph structure representation to the real world with the age and weights technique. So that help us to manage this problem, right? And then we need to model creation, develop mathematical and computational models that represent the physical world, like create a fluid dynamics model of the traffic. Step 4. Step 5, algorithm development. We are solving that, problem by program. So some portion which I talk, it was about the data. Now I am talking about the algorithm. Algorithm development, creation algorithm to process the data and solve the, a problem within the model. Like, if I give you one example, like for instance, develop a AI algorithm to predict traffic pattern and optimize signal timing. And then if I talk like simulation and testing, here is the algorithm part. You remember, run simulation and test it. If I give an example like use historical data to test AI prediction and optimization. And after that implementation, so we need to apply cyber world solution back to the physical world. This is the point. So implementation, we bring simulation, we bring the physical world to the cyber world. Real world to the cyber world. This is simulation. This is implementation from cyber world to the real world. So this is the very important part. And then we need to continuous improvement, collect the feedback. This is, we will talk, continuously update the AI with the new traffic data, like reinforcement learning, something like that. So by translating real world problem to these component, we can leverage the power of the computer to find a solution that might be impossible through the traditional mean. So this process is at the heart of how AI and big data technology transferring, right? Using some medical and healthcare issue. So as you saw, that data and algorithm is the core of the digital solution. So to wrap up our discussion, let's focus on the core element of the digital solution, data. So this is the data part. Let's summarize. Type of data is a structured data, structured data like database, unstructured data like text and image, sometimes semi-structured like John's file. Big data characteristic, we will talk volume, velocity, variety, value, and data collection method, IoT sensor, web scraping, user-generated content APIs. Data processing, cleaning, normalizing, feature extraction. Data storage, distributed system and cloud storage and data lacks and problem. So this is the take data issue. And another one is the algorithm. So whether traditional algorithm like sorting, searching, graph algorithm, usually a traditional algorithm means we need to give and tell everything to the computer. But the new sort of algorithm like machine learning, like supervised technique like regression and classification, unsupervised learning like clustering, reinforcement learning, these are three parts of the machine learning. So, or deep learning, neural network, conventional neural network, CNN, RNN, recurrent neural network, we will talk later in the coming slide. And we will implement really. So, but before that, we need to some theoretical part. Some algorithm design like efficiency, scalability, robustness, algorithm implementation like programming framework like TensorFlow, PyTorch, we will talk. And something interplay between data and algorithm, like data-driven algorithm selection, choosing the right algorithm based on the data characteristic, or algorithm-driven data collection, using algorithm to determine what data to collect, and interactive improvement means refining algorithm based on the new data and vice versa. So this is something interplay between data and algorithm. So data-driven algorithmic selection or algorithmic driven data collection is two different concepts. So as we progress in this course, that will really deliver to the concept, in deeper various type of data and algorithm, exploring how they've used in the real world AI and big data application. We will later on examine the historical development of this concept from early database system and simple algorithm to modern big data architecture and advanced machine learning technique. So understanding interplay between data and algorithm, as I draw here, is crucial for several reasons. Why? Because it really gives us choose to find the right tools to a specific problem. Really, it's helpful for us to understand limitation and even potential biases in our solution, and also guide us to develop of the new AI and big data technology. So by mastering this core element, we can harness the full potential of the cyber world to address most big challenges in our physical world. So if I go next slide and recap our slide. As a recap, we explore the concept of multiple worlds, like physical, cyber, and their interactions. We discuss why we need computers and AI to solve the complex problem. Then we examined the process of bridging the physical and cyber world. Then we look at the physical perspective on these worlds from the Plato to the modern thinker. We also delved and broke down the component of digital solution, data structure, and algorithm. We traced the historical development of data and algorithm somehow. We will talk more about this in detail and technically, and we will do something. We explore the relation of the big data and AI. Also, there is some key that cyber world, let's use some pen. Cyber world extends our problem-solving capability beyond what's possible in the physical world alone. Understanding both physical and cyber world is crucial for leveraging AI and big data efficiency. And interplays between the data and algorithm drives development of the AI and big data technology. As we continue to merge that the physical and cyber world, we open up new possibility for the innovation and progress. In our next lecture, we will touch to more DIKW, which is Data Information Knowledge Wisdom Pyramid, and try to more talk about the program and data structure in this pyramid, and then try and talk about some analytics in the data, information, knowledge, and wisdom, and which is important for our techniques which we are going to deal with. Okay, thank you for your attention during this introductory lecture. Lecture 2, we've covered a lot of ground today, from philosophical concept to practical application of AI and big data. As we continue this course, I encourage you, reflect on how the concept we've discussed related on your own experience and technology. Try to think about until next week. Consider the potential implication of further merging of the physical and cyber world. Start thinking, please, critical thinking. Please, this we are limited in the cyber class, that you need to start thinking about the area in your field of study. Everybody has a different field of study. Or future career where AI and big data might make a significant impact. Please remember that the field of the AI and big data is rapidly evolving. What we discussed today is just beginning. Please understand this one and understand this issue, that stay curious, keep learning, don't hesitate to ask any question. And in our next slide, we will touch very hot topic and very interesting topic. Okay, thank you again for everybody, and I look forward to our next class.